All right, I think we can start. Hi, everyone, and thanks for joining this webinar today. My name is Maxim Borisov. I'm R&D product manager here at Altium. And today I would like you to show some of our new capabilities, new routing agent capabilities we prepared for Altium Designer Release 20. That will be a three-stage webinar. The first one will be kind of short introduction to what kind of ideas we put into a new routing engine, what goals we're pursuing, what actually you can expect, what our plans, what were our goals, and what is actual positive impact. The next stage will be a live demo. I'll be using some of the boards I've previously designed, and will show you completely all functions that are new in Altium Designer 20 and which we're really proud of. And the third stage will be questions and answers. You can actually ask whatever you want or everything you are interested in. And there will be also a poll which you can actually use to, let's say, highlight some of the most required, most demanded functions in your everyday practice that you would like to be included in some upcoming version of Altium Designer. Okay, let's start. In Altium we have quite some long-term R&D projects, but there is one quite special because it's related to the very core of the product. It's all about router. Several years ago, we formed a completely new team from industry veterans, seasoned professionals, and as well as young talents, and give them, very serious task to develop completely new router engine that could match, the growing needs in new functions, performance challenges, and it could be, well enough to integrate into upcoming versions of Altium seamlessly without any need of, global modifications or global platform changes, seamlessly and without, unnecessary efforts. It's been a while, and now there is a, let's say, 4 main domains: the router itself and some subdomains of the router, which actually are mostly influenced by the recent changes. Actually, the whole new router give serious performance boost for general and advanced routing, trace editing, and tuning. There are several key features and several challenges that were kind of special interest for us. It's not only performance boost, not only geometry quality, but some high-level features like propagation delay support in all modes, including routing, tuning, and sliding. And of course, better support of odd angle segments, arcs, and similar geometrical objects, including T-junctions. It's especially required for designing modern PCBs, for modern processors, graphic processing units, and modern ASICs. So basically, we wanted to make something future-proof and scalable that could work in most, if not all, design environments. There were also key architecture concerns and also something related to user experience. First of all, we would like to keep the good tradition in Altium, to keep the possibility to open any project made in early version of Altium Designer in current release, and this is well sustained, that is kept, so we don't have any plans to change it. Everything is supported, and we have 100% back compatibility across all versions. So for this release, including completely new rotor engine, situation is the same, so it's not affected. And the thing is, we try also to make it, let's say, easy to learn, easy to develop your own design methodologies, and also to keep smooth learning curve for any generation of PCB designers. It could be like newcomers, some seasoned guys, and many competitors right now have like an interface and the whole ideology of EDA suite that stuck probably in the year 1917. They just can't go any further, and in Altium we just can't afford that. We need to actually to keep the product adaptable to many users, because we have lots of many users, and our community is extremely diversified. There are many different demands. There are many, let's say, design domains where you have, let's say, a designer for high speeds, signals and power supplies, means polygon layout versus high-speed layout. Absolutely different needs, absolutely different goals, and we just need to keep not all our features powerful and capable to perform accordingly to needs of our users, but also provide good access to them. Because if there is let's say, the power in the feature, but usage of this power requires even more power, that obviously doesn't make sense. And what's also very important, the Altium has a unified environment. That means you don't need to purchase any add-ons. There is no sophisticated licensing scheme. Just right from the box, you can get everything. There is no need to separate EDA suite to, let's say, less or more powerful instances. You just have everything you need right from the start. And as it goes from with the compatibility across all versions, we want to keep it same for now, and future versions means no need to change licensing options, and of course no paid add-ons. So what are actual results for all three domains, which I demonstrated a couple minutes ago? Let's start from the routing. For now, we have best-in-class router to handle odd angle segments, arcs, T-junctions, and later in the demo, I'll demonstrate you why it is so. There are three main subjects that make it really special. It's not only performance, which is extremely high, but the very quality of connection is sustained fine with smooth transition across all possible obstacles, objects surrounding, no matter what kind of PCBs you're actually designing. So the rotor engine itself is really independent of surrounding in terms of quality. It works fine and predictable under any circumstances. The next huge improvement is in trace editing. If you remember, in previous versions of Altium, there was quite a severe limitation when you try to slide arcs, T-junctions, odd angle segments. And in this version, we not just allow this to happen, but also added some extra features that made the process even more productive and give you even more opportunities. You can easily transfer from, let's say, arcs to lines and vice versa. And same situation as with the router. Connection quality, sustained, and all transitions are smooth and fine. No artifacts, no lack of performance, and everything is extremely transparent and predictable. And the third one, related to tuning, is probably most unique feature in the whole PCB EDA suite world, because now we have completely dynamic boundary for tuning feeling. Means you can move this boundary across the whole trace, change direction, and the feeling geometry will be updated online. It's not like a shrinked by nearby obstacles. You can see, and I'll show it later on the demo. It's intelligently filling all possible space. So it actually was the main goal we're pursuing when developing this tuning mechanism. Means effective usage of the space, and same thing, joints between filling pattern and surrounding traces are accurately monitored, and smooth transition and artifact-free geometry is kept. In summary, Altium Designer, let's say, not just take all the best from our long-term R&D projects, and you can now check all the stuff, feel its power, and I'll show something in the demo. I know that many of our users just tried open beta of Altium Designer. We have lots of positive feedback, but I would like to focus right now on these 4 words: power, performance, integrity, scalability, and just to explain what that means for Altium Designer 20 in the context of recent improvements of the roller. The power means we not just make the new features that are capable to handle current task better and some other tasks we were not able to handle fine enough, but we'll also added some extra features which are unique to Altium, and they just don't exist in any other EDA suites. So it's like a exclusive functionality in Altium Designer. Performance means we made serious homework on improving not the rotor engine itself, but the whole platform and how the corresponding blocks inside of software interact with each other. It's true for trace routing, polygonal routing, DRCs, all stuff like that. Basically, there are no any bottlenecks that could cause severe performance drop, which, let's say, maybe design specific, application specific. So that all is kind of future proof. And like I said, it works fine in absolutely most, if not all, situations. The integrity means we retain the unified environment within the whole Altium Designer suite. There is no, let's say, I'll compare to some of our competitors, like 3 completely independent schematic editors. You don't need to keep separated tool to create path stacks, to maintain that, transfer them between PCB editor and back, all stuff like that. You don't need to define, let's say, path for your libraries, for path stack somewhere in the depth of the software. Everything is right in your hands. And like I said, everything that's really required for PCB design, for creation collateral like manufacturing docs, reports, absolutely everything is within Altium Designer. No need to use, any other software, paid options like sub tools, sub programs. And finally, scalability means we don't have, let's say, built-in design methodologies. There is a freedom, and for now, Altium Designer is the only IDE suite that can afford that. Any user, no matter her and his design preferences, can establish the corresponding design methodology exactly as he or she wants. That's true for individual designers and for large teams. It could be, let's say, makers, students, but also large businesses, corporate enterprise. Everyone actually can find, let's say, their way that's works best among all others. You don't need, let's say, change your design process because the tool defines you. Not really. You control everything. So in my opinion, that's probably one of the most important benefits Altium Designer can offer. Okay, now it's a demo stage, and I would like to use one of my designs in a sec. First of all, I would like to show the new free angle tangent arc routing. In the previous version, if you would like to make some, let's say, free angle routing itself, some short, let's say, more efficient connection in terms of space usage, anytime you try to enter this corner style, it could be challenging to build the whole geometry, properly, because starting to clip or just, let's say, couldn't make the whole geometry with sufficient quality. But now we have this. You may ask, is that a sort of a snake routing? Well, not really, and I'll explain you what is so. Here we have kind of regular BGA, 1 millimeter pitch. I have completely ordinary vias here, 02, 045. But what makes it so special is that we have non-standard fan-out strategy here. Instead of 45 degrees orientation, I have 30, and reduced the distance between via and pad itself. Still, I retain reasonable clearances between objects. The minimum is 0.1, so there is no any advanced technology behind that. It's just an ordinary example, and this probably is the kind of challenge that classical implementation of snake routing can handle. No chance it can, because all existing implementations of such routing techniques, they rely on symmetrical channel in surrounding obstacles. And if you start to, your regular routing procedure in environment like this one, just won't handle that. But Altium Designer can. I'll start the routing. Have nice mode, and check this out. Maybe I could remove some of these tracks, maybe this, and just start routing somewhere here. So we can see it's making tangent arcs across the obstacles. I've intentionally made these small artifacts, and I show you what we can offer to get free of all these things. I'll select all such tracks. This one, this, and I just close them. So what are these tangent arcs? First of all, you can see the center of the arc is right in the center of corresponding obstacle. And we have smooth transition here. The trick is probably the most you can achieve with existing snake routing will be something like this. That's a later version of this board. I'll select this trace. You need to be extremely precise when moving the cursor, and you need to be extremely precise to make something that looks like a tangent arcs, because it just can't handle the wall connection in terms of smoothness and efficient usage of the space, and of course the lack of DRC violations. It's very hard to make some artifacts there. Right now I'm talking about the other EDA suites, but Altium not only capable to do routing like this one, but also capable to, let's say, change the whole design of yours when you have, let's say, undesired segments, zones with layout you just don't like. You want to improve the quality of the connection, and in sub-seconds, you just main, fine shiny. You may ask, what are actual benefits of using this kind of technique besides just capable to squeeze in reasonable and adequate way through all those obstacles while retaining the geometry? I'll use this board and I'll explain you. First of all, you are able to utilize outer layers, and not only outer layers, much more efficiently. If you, let's say, place fanouts as usual, like in the very center of this area, you will block all possible headroom to use, let's say, free spaces between the paths. While in this technique, with this technique, you're able to route probably in all direction, even from the very center, and even from, upper left corner to very left corner. And in practical meaning that most probably 90% of probability will give you a severe reduction in layer count. For example, this design, this particular CPU is usually routed on 10 layers, but here we have 8 layers. And it's just only this routing, but this is not all. It's very useful for high-speed designs. Here I have set up with odd angle segments and arcs. And when you use this technique, this new rotor, it's possible to not just, let's say, keep everything, better grouped, for example, keep byte lanes on their corresponding layers, but with this very important property where we have shortest possible path, because that is the shortest possible path, it will be easier to proceed with the length tuning, because once we have this short path, that is naturally reducing the target length in the match group. And even in situations where you need to, let's say, put traces not in the manner where it's, let's say, convenient, but in a manner where it's just physical possible, means you have quite large mismatch within match group, it will still help you because you can effectively combine arcs, which obviously provide you smooth and short transitions, with odd angle segments. Sorry for my bad pronouncing. I'll demonstrate you. Oops. We have a new control here called mean arc ratio, which actually allows you to effectively switch between arcs in free angle mode and regular traces. Let's say I have right now the 0, and obviously there are arcs, tangent arcs. That's very important. But when I put some other values, I have traces. And it works exactly like that. So basically, you can see this kind of routing. And like I mentioned, that's a real board. You can see such routing here, odd angle segments combined with arcs. So you have quite a freedom. And there are a couple more important benefits that usage of this function may give you. Even with extremely crowded environment, you can easily retain the good power integrity, at the same time keeping all decoupling capacitors and the target integrated circuit on the top layer, because as it was mentioned previously, I managed to utilize auto layers better. Some other layers underneath, which are usually used for signal routing. We have top layer, power plane, this is ground, and this one is usually used for signals, but now it's intentionally used for power, which allows you with let's say more dense placement to improve efficiency of all decoupling capacitors by reducing the spreaded inductance, marginal inductance, and of course mounted inductance. You have quite some place to drop, let's say, low inductive fan-out patterns and still maintain sufficient headroom for length tuning, other kind of routing, everything you need. So there are tons of benefits which usage of such functions may actually bring into your everyday design routine. As I mentioned at the very beginning of the presentation, we also have tweaks for basic routing functionality. Let me demonstrate you that. We have miter, which obviously will help you to maintain artifact-free geometry and I would like to pay your attention that it's ratio. I'll explain later why it's so. It's not like a, hard-coded value, but exactly a ratio. If I put traces like that and try to run, let's say, free angle segment, it won't allow me to make a kind of sharp angle connection. It will maintain this kind of arcs. And even if I switch to lines, that will remain the same. And basically it works in any circumstances. That's a common property for routing, sliding, and tuning. So this mechanism maintains high quality geometry in all three domains, which, let's say are born with a new rotor engine. There are other important controls. Oops, give me a second. Occasionally pressed some other buttons. There's a pad entry stability. It's a very simple tweak with a minimum stability. I can get a behavior like this one, so you can easily make an entry to any point on the pad edge. So it's not like a hardly snapped to, let's say, the center, the vertices. Actually, you can use whatever you want, but with the maximum stability, it's hard to control. So it will help you to maintain this exactly centered entry into the pad edge. And for, let's say, mainstream situations, you may probably would like to test the normal pad entry stability. And what is special here is that the segment before first turn is controlled by meter ratio. So maybe quite convenient in certain designs when you have, for example, long and short paths combined in one part. It could be, custom footprint, connectors, any kind of routing. And what actually this function can do in such situation is avoiding teleportation the cursor from one point to another, while you can easily control gathering the pad entry in, let's say, any scale, no matter what actual sizes of the surrounding objects. So it's very convenient and can increase the productivity in just any designs, no matter is that like a basic routing or some high-speed stuff. Let's talk about sliding, the trace setting operations. Like it was mentioned, we now have support of sliding arcs, like this one. And they're also possible to push surrounding. Like this. You can actually change the way of how surrounding obstacles are pushed. Like I said, it's quite easy to switch between lines to arcs. So very easy and very fast performed. There's opportunity to slide T-junctions. Let me make it more complex. I'll try to add some odd angle connection, like this. Also possible. So these are quite a high performance functions, and I'll tell you later, better say I'll show you a bit later, what means the speed when you're working with large objects, like, you know, this BGA. There is also opportunity to select T-junctions and also push traces. And I would like to also show some vertex editing operations. Let me put ordinary trace like this. You can see I have this new menu, vertex action. Now it's smooth, so it obviously will create tangent arcs. You can deform it, so basically it works like that. And you can scale it, means you'll take the corresponding vertex with surrounding neighbors. So there are quite a freedom of how you can deal with the traces in your designs. It could be like a regular sliding, or you can use some vertices and make the whole connection compact, smooth, very handy in post editing, and probably I should say probably it's will show the its power in sliding some tuning elements in post stage, when you just, let's say, want to tweak the geometry to avoid some free islands, make everything more compact. Basically, such objects are a mix of some traces, arcs, and you can obviously select whatever you want that fits your needs best way. So this is quite handy and quite convenient. Let's talk about performance of these functions. I will drop this BGA over the board, hide connections for a while, and I'll try some death trick. I'll enter this mode and select the walk around. What I would like to do is to try roll the trace across the whole BGA on the diagonal. Let's see what will happen. Maybe this, this, this. So you can see it takes sub-seconds to perform. The whole connection is made with tangent arcs. And it's, for now, it's not arcs, it's odd angle segments, but they are tangent as well. So you can see it's made perfectly and placed efficiently through the whole channel. And basically, it takes sub-seconds even for larger BJs like 1K pins, 2K pins. It's a very fast-acting feature. And let me try something similar for sliding. I'll use this pin, change the mode for now. Okay. We have now rounded mode, so it will eventually make some marks. So you can see, even for this computational intense area, we have nice, good arcs across the wall connection. Let me switch it back to the default state. I'll tell you a bit more about why we use ratio here, not the actual values. Let's slide this segment. You can see it retains the geometry, but for now I would like to use mixed mode. It's a kind of bridge between regular 45 degree mode and U rounded. And we have this mean arc ratio field, which is quite similar to rotor, because like I said, it's these are common properties, and the whole core is monolith. So if you understand it, you know, you got the point in one domain, you're ready to use it in any other. I'll change the values, and you can see it's transformed into lines in the areas of transition. I'll make it meter ratio a bit smaller, so it could be, you know, more obvious to recognize this geometry. So as it was shown for odd angle segments a couple moments later, you can effectively switch between anything and maintain geometry, the quality of the geometry along the wall trace quite easy and with minimum efforts. Let me explain why we use the ratio for meter. For small values, you can see it's creating kind of small segments, which can be beneficial in, you know, when you walk around like small obstacles, you need to squeeze between them just to tweak the direction. But for larger one, let's say you don't want to have this kind of segments. Let me put something real large here, so we can see the character of the glossing was changed. So you now are able to gloss the whole trace and, you know, effectively squeeze in between surrounding obstacles, like a, sorry, I pressed escape occasionally, like the whole trace, not like, you know, the single segment. And this is why we made it like a ratio, because classical implementation of meter won't allow you to do that. It's kind of hard-coded value, which, you know, can only make kind of fixed length for, you know, outcoming segment, which in such environment will probably cause nothing more than DRC errors, because it's just impossible to, you know, place that value and maintain meters in turnovers, hanging all the paths, other zones, especially when you have, you know, room here with one kind of definitions for clearances, for width, and on the edge, you'll probably will get yet another artifacts. Violation of geometry means not quite a good connection. That's true for classical implementation of meter. But here, as you can see, a rotor can recognize obstacles, its surrounding, and use user-defined presets in quite intelligent way. You can play with those values, and no matter how large or small values you use, actually it will effectively stop you from making, let's say, some undesired artifacts which are really hard to fix, where they happen, let's say, not in area of your interest, but, you know, somewhere else. Because if you define large emitter, you slide somewhere, let's say at the start, and because it's large, it will also gloss somewhere closer to the end, and you may not notice that. Let me show you something about, let's say, the mix, the actual border between routing and sliding itself. I mean, the pushing the traces when you are in a free angle mode. Let me double check these values. Okay. So when you start to push the traces, it effectively, oops, walk around objects. It effectively recognizes the surrounding. It can either put arcs or lines, exactly as you defined. Maybe I'll remove that overwhelming masking so you could easily recognize that. So you can see it could be either traces, completely regular traces, or arcs. So it's true for any domain. Routing, sliding, tuning, you have complete control over everything. I think that's it for sliding. Let me show you something we prepared for length tuning. Oops, let's come on. Here I start to place a matching boundary. I can effectively switch the filling pattern. And here's the main trick. I can do things like that. Moreover, I can change the whole orientation of that and place it like this. It's not kind of clipped somewhere by, let's say, the virtual boundary within this box, like many other competitors' software does. It can effectively squeeze into its surrounding. Let me try again. And of course, you can't lose that boundary. For example, if I try things like that, it will return. Same story for differential pairs. Let me reduce it. And start the same thing. You can see I can change the actual meter style. Let's give it like that for a while. And I can do completely the same thing. And these joints are effectively controlled by the meter. And the meter is, let's say, the common, very strong functional block in the new rotor engine, which prevents you from making undesired geometry artifacts, some DRC violations. And together with new tuning engine, it allows you to utilize space in extremely efficient manner. You can move the whole boundary whenever you want. It will also work for odd angled segments. Let me intentionally remove this one, just to show you how it will feel surrounding area. Hide all. Just to confirm, that's exactly that kind of trace that we managed to get the previous stages, odd angle segments. And you can effectively slide the boundary in any direction, change the amplitude. You can see, so recognizing its surrounding. So extremely serious boost for high-speed designs. And it's fast acting mechanism. it's working fast, no matter how dense is your board. There's serious power at the very basics of this, because it's not like let's say another block of software which existed independently. That's a monolithic core, and that brings unparalleled performance in all applications without severe negative impact on the board size, board complexity, which in its turn means makes it more and more easier and affordable for server level designs, that kind of scale and complexity, and other projects like that. So basically, like I said, it works fine, fast, and quite transparent under all circumstances. Let me show something about propagation delay. Sorry, tools, we said there are markets. I was moving there. I have separated rules of this region. If I select this trace, you can see I have exactly value of delay. And this is very important because in Altium 20, we have built-in electromagnetic solver from Symbior. It's known for extreme accuracy. It's a field-proven simulator used for most high-end applications and speeds like 112 gigabits and more. It was proven in multiple applications, especially in the servers, HPC, artificial intelligence domains. So this is available for Altium. And what is really important, you don't need to calculate important physical values to make it operational. For example, you don't need to calculate propagation velocity factor, because the only things this solver should know. It's part of built-in in Altium. The only values required are length of the trace and actual geometry. It will recognize is that a single-ended trace or differential pair. It will recognize coupling within differential pair, yes. And it will also take all physical parameters from your stack-up, including edge factor, covering with solder mask, amount and type of dielectrics, I mean the accurate physical structure of whole transmission line. And of course, the calculation of delay is available for any kind of objects. I can select arcs. It will show me the exact delay. I can select the whole trace. And if I click here, it will get me through this PCB panel. Oops. So I can easily monitor everything here. You can see with same length, physical length, I have differences in propagation delay for differential pairs because, like it was mentioned, it takes into account the coupling within segments of differential pair. So it's really smart and powerful feature essential for high-speed designs. You can also assign propagation delay for any paths in a straightforward manner. Previously, we only had this field, but now you can do things like that. It will recognize it. And next time you want to double check the actual delay, you will see that you have the total delay provided by the physical trace, and also there's added delay by the pad. Same story for the via. we have propagation delay here, so it works equally. And needless to say, all such features are supported during rolling, during sliding, and during turning. So it's a monolithic thing, extremely powerful, and what's really important, it's very scalable, because now what we managed to get when I was working on this long-term project is ability not just make, let's say, deep modifications of the platform routing engine, but add required functionality in, let's say, incremental way. It's way better, and because we have fast development cycle, it also means we can deliver that to the users, quite fast, and provide appropriate solutions for growing demands. Let me also highlight some important changes in UI. We have, as you could notice, this new preview, different from earlier versions of Altium Designer. You can control important parameters of transmission lines, length, delay, and net classes. This is interactive section, and as it was demonstrated, once you click to any fields, it will take you to the PCB panel, so you can check all nodes, all properties, and if the net is in a class, you can check class, and other important things. So we have complete information about objects you're working on just right in your hands. We have this assign net button, very important. It's very handy in a polygon layout. You can just quickly select the net that you would like to assign. It's working with, give me a second. It's working with filters. So if you select the appropriate filter, like let's say you want to pick up traces and paths, but you don't want to pick up polygons or fields, you can set up filters accordingly, and it will pick up only those objects you would like to use for being a donor for the net. We have new 3D preview for pad stacks, and I would like to highlight that it is for pad stacks, not like only for pad, for VS. It will show the whole physical structure. You can effectively scale it up. You can rotate it. So it's quite handy. And very soon you will be able to select corresponding pad stack and just get to the physical properties of the pad shape, which is quite convenient, especially if you have a multi-layer design. You really don't want to sift through all those parameters, but you would like to visually, select, actual pad on required layer, assign new pad stack, suppressed unused, change thermals, control back drilling, things like that. Quite convenient. And we also made all previews for objects hideable. So you can, the right object. Let's say if polygon, you can just hide everything, and that's it. That's for all type of objects on the PCB that have previews. So you can fold the whole sections. You can fold previews if you are, for example, seasoned user and don't need some previews here. You only need controls. you can do like that. If you are new or need some, let's say, more info about that, you can set up interface of interactive properties panel exactly as you want. And here, by the way, for Polygon, we have this action bar, which is quite handy for Polygon layout. It's also a part of the global improvements of the routing. So as you can see, there's lots and lots of changes, positive changes here. And what I can say, that's only the start, because let's say we prepared not just the whole bunch of other features, but we also prepared some extra, like I said, unique to Altium Designer. And very soon you'll be able to see how it works, how they can get positive changes in your everyday work. And the weight, the size of recent changes is also grown. So let's say the release Altium Designer 20 in this context is quite different, because we not only made the huge work on improving the whole platform, fixing the bugs, introducing this new router, implementing idea from our community. We also change ourselves, and we now greatly focused on not just, let's say, releasing new features, releasing some certain functionality to match demands of the users. We also would like to help you to adopt those features, which is quite important. For this, we are preparing some how-to videos, guides, and these are not kind of, let's say, copy-paste from wiki. These are completely applied documents, which allows you to adopt new features easy and fast, increase your confidence in the tool. One of these two will be about this kind of routing, how you can easily adopt this for your designs, for your needs. And of course, there will be the whole anatomy of new controls, new functions, meter, mean arc ratio, the whole geometry tweaks, so you can easily see at which stage you can use it, how you can use it, what is the impact, and it will be very, very short, very clean. So no need to, let's say, remember the jokes about reading manuals that turns into a full-time job. So quite some positive changes.